Hi everybody. So in this video I'm going to show you how we evaluate an integral between two known limits. So in example A, we've been asked to work out the integral of 2x with respect to x between the limits of 0 to 3. So we evaluate this as we would a normal integral, and then we substitute in the limits of 3 and 0. So if we integrate 2x with respect to x, we get 2x squared divided by the new power of 2. And then ordinarily we would have the constant term. Now we don't actually need this constant term, but I'm going to include it just to show you why it disappears. And then we have the limits in the top right corner of 3 and the bottom right corner of 0. And then you can see we can simplify this, so this becomes x squared plus c between our limits of 3 and 0. Then all we do is we substitute in the 3 in place of x, and then we take away when you substitute in the lower limit into place of x. So this will be 0 plus c, and then we can close that bracket. So the reason we don't need the c term when we perform a definite integration is because you've got the positive c term here, and then you'll have a negative c term, and these will cancel each other out. So we've got the 3 squared minus the 0, and this will equal 9. Okay? For question B, to evaluate this integral, we need to expand out the x. So we get the integral between 1 to 2 of x squared minus x integrated with respect to x. And then we integrate the x squared minus x. The x squared becomes x cubed over 3, and the x becomes x squared over 2. And then we can have square brackets around this, with the upper limit in the top right and the lower limit in the bottom right. And then we substitute in the 2 in place of the x, and then we take away when we substitute in 1. We can evaluate each of these brackets, and we get 2/3 from this bracket and negative 1/6 from this bracket. We'll add these two together, so we'll get 5/6. Okay? Let's try another question. Okay, so in example 2, we've been asked to evaluate the integral of 2x squared plus 3 over root x with respect to x between the limits of 1 to 4. So perhaps you want to try this question yourself. You can pause the video, and when you come back, we'll go through the worked solution. Okay, so welcome back if you're ready to go. To evaluate this integral, I'm going to split up this fraction, and we'll write this root x as x to the half. And then we can use the division rule of indices to simplify each of these. So we get 2x to the 3 over 2 minus the 3x to the negative 1/2. Then we'll add 1 to each of these powers and divide by the new power to integrate this. And at this point, we can move this division to the numerator and this one as well. So now this will become 4 over 5, and this will become negative 6. And then we can substitute in our limits of 4, and then we'll take away when we substitute in the 1. So here we'll get 68 over 5, and here we'll get negative 26 over 5. And this will give us 94 over 5, or 18.8. Okay? Let's try one more question. So for example 3, we've been asked to work out the value of t when the integral of 8x minus 12 between the limits of 2t and negative 2t equals 0. So the first thing I'm going to do with this is I'm going to factor out the 4 from this bracket, because that means I can pull that 4 in front of the integral. And then I can just divide both sides by 4, and this will become 0. And then we can integrate the 2x minus 3 with respect to x. And then we can simplify this to make x squared. And then we'll substitute in this upper limit, and then the lower limit. Then we can work out each set of brackets. So we get 16t squared minus 12t here, and 4t squared plus 6t from here. And this will equal 0. We'll expand out this bracket, then we can collect the like terms, and then factorise the left-hand side. And we're told here that t cannot equal 0, so the 6t won't be our solution. So our solution would come from this bracket, and t will equal 3/2. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe, and you can download the full lesson and worksheet from my website, mrmathematics.com. I'll leave a link in the description below.